Hi, let's take a look at notes 5.3. So the first thing we're going to do is look at these four steps. And the very first step says determined, we're going to solve rational equations. Remember, equations that are rational, they just have variables in fraction form. That's really what that is. And we can see these are equations. These are different than the expressions we saw. And in my opinion, I think equations are actually a little bit easier because we can get rid of the fraction, which we will do in step 2. So the first thing we need to remember is that whenever you have a fraction and you divide by 0, it's going to it's going to give an undefined value. And so step 1 first says determine all values for which the rational equation has undefined expressions. So in example 1, the only denominator is 2x plus 1. What I want you to do is pause the video, set that equal to 0, and see what value would make that undefined. All right, in example 1, what I found was the denominator equals 0, and solving, I found that x equals negative 1/2. What that means is if I put negative 1/2 right in here, that would give me a 0 in the denominator, and that just isn't possible. That's undefined. So at the end of all of this, I'm going to have to check and make sure that I didn't get that as an answer. Okay, that's all step 1 is doing. So you'd have to reject any answers that would be undefined. Step 2, we want to clear the fraction. To clear the fraction, we want to multiply by the least common denominator of expressions. Well, this one's pretty easy. 1 is over 1. So the lowest common denominator is going to be 2x plus 1. So I'm going to change the color here so that I'm going to multiply. Now I'm going to have to multiply both sides. Okay, this is step 2. So I'm going to multiply by 2x plus 1. Now, when I multiply 2x plus 1, because it's an equation, what I do to one side, I do to the other. Now, why did we do this? Well, we want to clear the fraction. We really want to get rid of it. So this 2x plus 1 and this 2x plus 1 right there, they cancel. And so it's a 1, but you don't really need it. And all you're left with is x plus 2 on this side. Nothing was needing to cancel here. And if I distribute that 1, it's not going to change anything. So that's 2x plus 1. Solving, I'm going to subtract my x. And then when I subtract my 1, it looks like I'm getting a value of x is equal to 1. That was actually step 3 to solve the resulting equation once you've cleared the fraction. And then step 4, all we need to do is to make sure, is this value okay? Yeah, the only value we found was x equals negative 1. We didn't have it. That's not an issue. Okay, you don't need to cross that off. But this is our answer. We've checked it. This is not an answer. It's just, had I gotten x equals negative 1/2 instead, I would have had to have gotten rid of it. Okay, so let's go on over to example 2. So example 2, my first fractions are pretty simplified. There's nothing we can do to simplify them. So I'm going to leave them the way they are. But this last fraction, what we're going to do is we're going to change that to x squared minus 4. Okay, we're going to leave that to x squared minus 4. Oh, sorry, I don't want to leave that to x squared minus 4. I want to factor that. And the other two are giving me factor vibes because the x squared minus 4 is actually a difference of 2 squares. And so that can be changed into x plus 2 and x minus 2. Now, I forgot to determine for all values which the rational equation would be undefined. And that would come from here, here, and here. Which values would make those 0? Well, in the first circle, it would be 2. And in the second one, it would be negative 2. And same for the last two. So I'm just going to write those off to the side. We're going to say x equals 2 and negative 2. We don't want those. So I'm just going to say, no, we do not want those. Because again, if we put 2 in there, it's going to be undefined. And if we plug negative 2. All right, let's go to step two. Let's clear these fractions. So in the last example, I only had one fraction, but here you can see by the third fraction, I need to multiply by x plus 2 and x minus 2 to cancel them. That will cancel both of those fractions. Now, what I do to one side, I do to the other. So even though this one only needs x plus 2 to cancel, that's not a valid algebra move. You need to multiply by everything. Same with the first fraction. Okay. It looks like every denominator will cancel. So again, I'm going to refer to that word clear. I'm going to clear these fractions. So let's cancel. I'm going to cancel the x minus 2. And what that's going to give me is x and x plus 2. And in the second fraction, I'm going to clear the x plus 2. And that's going to give me the 1 and x minus 2. You don't really need the 1, but sometimes if it's negative, you would want to leave it because you'd have to distribute. And then in the last fraction, I think all I'm left with was an 8. Why don't you pause this, see if you can solve, and then just make sure that whatever answer you've got, you've checked and make sure 2 and negative 2 are not an answer. So go ahead and pause and then come back. All right, when I distributed, I got a quadratic. Well, quadratics, there's a couple ways to solve, but the most popular ways are quadratic formula and factoring. So I just went ahead and set that equal to 0 and factored. And when I use zero product property, my final answers are -5 and +2. But I want you to remember that before I started, I said, and I'm looking all the way at the top, that values that would make this undefined were 2 and -2. Well, guess what? I actually got a 2. This would make it undefined. That is not going to be one of the answers. This would be the only answer. Okay, when we look at looking at rational inequalities, we're gonna treat inequalities the way we've treated all others, and that is to use a graph. So again, the textbook does it differently than the way I do it. So first step is going to be rewrite the inequality if necessary so that 0 is on one side and there's a single rational expression on the left. Okay, so we definitely want to go less than 0, greater than 0, because less than 0 would be below the x-axis, and then greater than 0 would be above the x-axis. So that's going to be step 1. Step 2 is going to be graph, and step 3 would be right answer in interval notation. Okay. So yeah, step 1, but we're not going to do any of these steps here. Okay. And then let's go ahead and try. I'm going to do one and then I'm going to have you try one. So in example 3, the first thing we are going to do is we are going to graph. Now, the first thing we should do is rewrite this in factored form, and it actually is in factored form, so there are no holes. The other steps that we learned from section 5.2, I think, is how to find a vertical asymptote. Vertical asymptotes comes from the denominator equaling 0. And since I have that, I'm going to go ahead and add that to my graph. And this is going to be my vertical asymptote at x equals 2. Okay, let's also do a horizontal asymptote. Horizontal asymptotes are y equals, and we're going to take the limit as x approaches infinity. And I think this is a new one. We haven't seen this one. So it's x squared, because it's just the highest power, over x. And that's equal to x, because you could just simplify it. Well, if we were to plug in infinity right here, right, because this is just x. If we were to plug in infinity, there's no way you can have y equals infinity as an asymptote, okay? What we're looking at is, well, we would want to graph that like I did this. You could never graph infinity. So this one, there's none. You're just going to say there's no horizontal asymptote. All right, the other thing we need to do is we need to come up with x and y intercepts. So let's see if we remember how to find a y-intercept. And that is, remember, let x equal 0 and plug in. So let's do 0 squared over 0 minus 2. And that's 0 over negative 2. That is 0. So the intercepts are going to be 0 and 0. This is also going to be our x-intercept, but remember, x-intercept is when you set 0 equal to the numerator. And sure enough, we get 0, 0. So 0, 0 is going to be our intercept and our y-intercept. So now what we have to do is we have to test some points. There's no horizontal asymptote. So I just want to know what's happening. Let's say over here, 3, because I know there's a vertical asymptote. What I really want to know is, what does this look like over here? And so when I plug in 3, we're going to get 3 squared. Oh, wait, let me make a table, because I think I'm going to have to check quite a bit of points. Let me just make my table right here. So when I plug in 3, I get 3 squared over 3 minus 1. That's 9. Oh, 3 minus 2. So 9 over 1 is 9. So we'll put 9 way up here. Okay. And I'm pretty sure because that's an asymptote, it's going to keep getting closer. So now I want to try 4. 4 squared, that would be 16. 4 minus 2 is 2. So it'd be 16 over 2, which is 8. Let me try 5. 5. And this will be my last one, and I'll explain why. 5 squared, that's 25. 5 minus 2, that's 3. So 25, use a calculator here. 25 divided by 3, that should be 8.3. So what's happened is it started rising again. And to be honest, it doesn't really matter, because what I know is this graph is never, looks like this. This graph is never going to touch the x-axis again. And I know that because if it did, I would have had another intercept over here, and I don't. What I need to know, because remember that less than 0 is going to be, let me show you real quick, it's going to be everything below the x-axis. Okay, and I know that I'm scribbling all over my paper, that's fine. This is not above the x, or it's not below, so it doesn't matter. And it doesn't matter how close it comes. It doesn't matter how close it comes. It doesn't touch. There's nothing, there's no x-intercept, so there's just no way. But it could, right here, is it up here or is it down here? I know it crosses at 0. And then, is it up here or is it up here? So those are the things we need to figure out. So we've got to figure out a number that we can try. And in looking at this, I think 1 is going to be a perfect number because that'll tell me, is it above or is it below? So let me extend my table and do this again with 1, and let's plug it in. I think I'm getting -1. What do you think? So that's 1, because 1 squared is 1, and then 1 minus 2 is -1. Yep, -1 is what I'm getting. The last point I want to try is right here, -1. And I want to know, because is it above the x-axis? Because if it is, it'll stay up there. It never touches. There's no more dots on there. Or is it below the x-axis? If it is, it's going to stay there. It's never going to touch again. All right. Let me erase this. This time I want to try, I think -1 is what I said. Be careful. Whoops, I got to use the right color. When I square -1, that's +1. And then -1 minus 2 is -3. So -1 is 1 over -3, which is still -1/3. It's right here. So this graph looks something like this. This one actually has a horizontal asymptote. If you're interested in that, take a look in the textbook. Horizontal asymptotes occur when the numerator is 1 degree higher than the bottom. We are not going to cover horizontal asymptotes, or oblique. I'm sorry, I said horizontal. Oblique. Oblique just means that it's slanted. So it's going to be a line. And there's a way you can learn about these things. This is enough for information for most students. But if you're saying, hey, I already knew this stuff, take a look into section 5.3 and look into, or section 5.2 and look into oblique. But I'm never going to test you on oblique. No. Finally, my last order of business here, excuse me, is to answer this question. Where is the graph below the x-axis or touching it? And it looks like this. It looks like this. It's all of this piece, and since it says it can touch, I can go through 0, and I just keep going. So my answer is going to be from -infinity to 2. Now, normally, if there's a line here, we put a dot. But we can't put a dot. This is an asymptote. It's not a dot there. If there was a dot touching it, then we could. And the truth is, it does not touch the x-axis at 2. So this is the first time, I think, where there's an inequality with an equal sign, but you don't put a bracket. All right, I've talked a lot. First thing I need you to do in example 4 is make this a 0. Okay, otherwise it's a lot more involved. I want you to find vertical asymptote, horizontal asymptote, y-intercept, x-intercept. Find all those things and then come back. Okay, but push pause. Good luck. Okay, for the vertical asymptote, just remember to take that denominator, set it equal to 0. This is why I like teaching inequalities using a graph. We get extra time to practice those graphs. In 5.2, there weren't a ton of examples, so I like being able to just practice. Okay, try the horizontal asymptote if you haven't done so, and then push play again. Okay, again, what I've got is I did the limit as x approaches infinity. And remember, this is a y value. Horizontal asymptotes are y values. So when I plug in, or when I do the highest power over the highest power, I took x over 2x. I simplified and I got 1/2. You don't even need to plug in infinity. The x-intercept, remember to plug in 0. And the, y-intercept, x equals 0. And then the x-intercept, remember that is the numerator equals 0. So push pause, come back, and remember to write these as points, please. All right, when I plugged in 0 for x, I got 2 over 1, which was 2. And then I wrote that as a point and I graphed it. I went 0 and up 2. That's 2. And then for the x-intercept, I know y equals 0. So the only way you're going to get a 0 is if the numerator, it doesn't matter what's on the denominator, the numerator equals 0, and then you just subtract 2 and you get negative 2, 0. Because I know the behavior of rational functions, rational functions, that's actually pretty good. It's going to get closer and closer to those asymptotes. It's a little trickier when you have two vertical asymptotes. And there's that. Okay. Now, the only other thing I need to do is answer the question. This one, again, is less than or equal to, and we changed it to 0. Again, we could have done 1, but it does make it a lot more intense. So this is fine. Less than or equal to 0 is below the x-axis or touching it. And I have to tell you, this is all I see. And it goes, remember, we're looking at x values. So it starts at negative 1 and it touches at negative 1 and it says it's okay to be equal. So that's fine. But it stops, this is at negative 1/2, right? This is 0 right here. That's negative 1. And it does not touch right here. I can put it there, but that's not what the graph does. So that would be a parenthesis, and that would be your answer. All right, let's look at this rational function, and they want us to solve when it equals 0. So let's set E0 equal to, and we'll see this a lot more in the next chapter. No, actually, it is this chapter. So we know that when you have exponents to the negative exponents, you're going to bring those to the bottom. I know that's kind of messy. So we are going to bring x to the 4th on the bottom like that. And then the negative is not a problem. It's this x to the negative 2. We're going to do the same thing. We're going to bring it to the bottom, and that's going to be there. And we're going to follow those 4 steps that we checked before. So first thing, what values would make this undefined? Okay. If x to the 4th or x squared is 0, that's a problem. So the values that would make those undefined is 0, because 0 squared is 0, 0 to the 4th is 0. And remember, these are answers we don't want. So if we get 0 at the end, we have to reject it. Step 2, because there's an equation, we can clear the fraction. So what we're going to do is we are going to multiply by the lowest common denominator, which is x to the 4th. Okay, x squared would not work. Sure wouldn't, because it would clear the x squared, but it wouldn't clear the x to the 4th. So you need the bigger exponent. Now let's simplify. X to the 4th times 0, well, that just turns into 0. These cancel. That's 7. This is x squared. And this is x to the 4th. Now, you don't have to do this, but I'm going to rewrite this. X to the 4th minus 8x squared plus 7. Now it's in standard form. And I know this looks weird, but there's no GCF. And I'm going to try to factor it. I'm just going to use regular trinomial factoring. I think we've seen this in last unit's practice. I think if I use negative 7 and negative 1, that will actually give me negative 8x squared. Well, let me check. It worked, and then I just want to make sure that that times that is positive 7, and it does. So let me erase all of this. All right. Now we've got zero product property happening. And here you could factor or solve by adding 1, and I'm going to add 1. Just remember that when you put the square root, you have to remember plus or minus. Oh, I already said that. So let's add 7 to both sides. And then we're going to square root and plus or minus. My pen is getting tired. Okay. The square root of 7 is going to be 2 point something. I know it's 2 point something because the square root of 9 would be 3. So again, let me pull out my trusty calculator. And the square root of 7, there we go, square root of 7, is 2.6-ish. And it's going to be positive and negative 2.6. So we found this. Now these would be the exact answers. Okay, I would only use a decimal if they made me or if I were going to graph it. Now, example 5, it's continued here, and it says, use the graph to identify the zeros. Well, guess what? They've got a 0 at positive 1. They've got a 0 at negative 1. They've got one at 2.6 and negative 2.6. There we go. And then C says use that graph, because they're not going to ask us to graph this. This is weird. Use the graph to solve these inequalities. And let me move this guy for a minute. There we go. So we want to solve two different inequalities. So let's look at it below or touching the x-axis. Okay, that would be these pieces here and these pieces here. So for me, that is, and they're both touching and they're both bracket because they do touch. So I'm going to use the radical 7. I only use 2.6 so I can know where it would be approximately. That one goes from negative radical 7, negative 2.6-ish, to negative 1. And it's going to be union with this little piece, and that one goes from 1 to 2.6. But remember, we're not going to call it 2.6. We're going to call it radical 7. And they both touch. They both touch. Okay. Can you pause the video? Try to doing greater than or equal to 0. Try doing that, and then come back. All right, let's see how you did. It's from negative infinity to negative radical 7. Remember, that's that negative 2.6-ish. And then when I looked at this piece right in here, I thought maybe it was continuous, but I know that x could not equal 0 when we solved it in the example 5. And that also there's an asymptote, right? Because it had a denominator of 0. So you know that there's going to be something happening at 0. So I would do like that. That's why you have to break it up. And then it's going to be from 0 to 1 and then radical 7 to infinity. All right, your homework should be posted. Good luck.